Good afternoon to all of you. That's a bit of a false start. My name is Christopher Marsh-Bourdon. I'm a solutions architect at AWS. I work in the global financial services space, and today I'm joined by Justin Fox. If you've seen the keynote, you've already seen Justin. Justin is a member of NuData Security, part of the MasterCard family. He's an accredited AWS instructor at the Institute, or the British Columbia Institute of Technology, correct?
Yes.
So he knows far more about AWS than I do, which is a real crying shame as far as I'm concerned. But you're in really, really good hands for an interesting discussion around machine learning, and not just machine learning, the workings around machine learning itself as well, which is really fantastic.
Yes, it's really important to focus on the entire ecosystem. And I'm really excited to be here to chat through what we at NuData do. So with that, let's go to the agenda and talk a little bit about what we're going to cover today in this session. We're going to start by talking about what is NuDetect and what does NuData do. And then we're going to dive into how do you layer different threat intelligence models so that way you can do real-time model inference, threat detection, the whole 9 yards. And then we'll dive into how do you really get deep and your hands dirty with big data, data hoarding effectively. And then we'll talk a little bit about data ops, what I like to call data ops, which is all about how do you get machine learning models back into production as quickly as possible with as short a turnaround time as humanly possible. And then we'll talk a little bit about where we're going to go in the future and how we're going to go about our cloud journey. Quick note, there are some related breakouts for those of you interested in learning more about SageMaker, talking about a wide variety of topics. All these speakers are AWS speakers, and they're pretty good. I recommend you checking them out. So let's dive right into the meat. What is NuDetect, and what is the overarching problem that NuDetect and NuData solve? I'm going to start with our history. NuData was born in the cloud. It's a Canadian startup. Those of you who were in the keynote earlier already heard me wear this thin. I won't bore you with it. We were acquired in 2017 by MasterCard, and we specialize in real-time machine learning. We like to be the invisible consumer verification layer for enterprises everywhere. Our customers are global. They have challenges around GDPR and PSD2, a lot of EU regulations. The US is, of course, on the rise. The cybercrime landscape is terrifying, as I mentioned on stage earlier. It's even more expensive, especially as you think about insurance rates, as insurers are less likely to cover acts of cybercrime, especially when the security wasn't up to snuff. And how long until they just won't cover it at all for those who just use static username and password authentication? Username and password authentication is broken. And depending on the type of multifactor authentication you use, it can be inaccessible to some of your users, some of your customers.
And so, just on this point, I mean, obviously I'm in the financial services arena, but this isn't just focused on financial services. So what other industries are you covering with this technology at this point in time?
Any industry where we have a transaction occurring between a human and a computer, whether that's in e-commerce, gaming, or any industry vertical, what's important to our technologies and how we identify users and give that positive consumer experience, it's all around having a login event, a shopping cart checkout. Any sort of human interaction is where you can use our software to detect fraud. And
so how are you trying to counter this threat? What are the technologies and the processes you're using to do this?
Pretty much everything's AWS.
Okay.
A little bit of middleware here and there, but we really want to dive into how we use SageMaker, how we use EC2, how do we use all the different load balancing tools, what are the compute things that we do behind the scenes to make the magic happen.
Magic.
Why does NuData care? This all focuses down into why I care as well. Why is this important to me? Accurate authentication is critical to make sure that with all the data breaches occurring, all the credentials, all the account records that are out in the open, touching and impacting many of you here, how can we stop people from basically pretending that they're you? How can we prevent synthetic identities? How can we stop account takeover fraud?
Okay, and so you've got the technology in place. So in terms of what are the kind of threats that you're looking at, and how are they attacking the user base, as it were?
You go online, you want to buy anybody's credential, you can find it typically for as low as 20 cents. If it's a verified user, the higher end of the scale, we're going to see like a $15 verified user for somebody's bank account. That gives me a really heavy feeling in my stomach when I think about the possibility of that impact on my life. And I'm sure each of you here, it would devastate you if that occurred to you. If somebody took over your account for any reason, whether that's just your shopping, whether that's your bank account, it's very impactful to your life. Simply by exposing the online endpoint, fraud can start occurring. You launch a new service, people grab some identities off the black market, they're able to apply it to your service to create accounts, to masquerade as that user, to do credit card transactions even. Standard controls like network traffic firewalls, like WAF, web application firewalls, or just distributed protection in a CDN is not enough to just prevent exploitation, because quite often this is within your application. So those controls are not enough. What you need are layers of security and threat intelligence. And when we think layers at NuData, we think of combining those layers to give a complete holistic protection of the entity, whether that's around the device, behavioral analytics, passive biometrics, which is really exciting and cool, or our real-time trust consortium, where we're really looking at account history. Each of these categories runs on numerous machine learning models.
Yep, so what exactly, can you explain what each of these things actually do? Because obviously it's a great title, but what do they actually mean? What's underneath the covers?
So I'm going to focus on passive biometrics because it's very invisible to consumers. This is how you hold your device, how you interact with that device. If it's a mobile phone, that can be just the angle you hold it at. It can be how hard you press the screen. And looking at device intelligence, this is geographical information, unique device identifiers. And
sorry, none of these are like PI information. It's just, it's information about you, but it's not, it's specific to you as such. But it's not like your bank account details and your logon, etc.
Correct.
Yeah.
Correct.
Okay.
So with this, we're going to slide into a quick intro video, and then we're going to dive right into front-end architecture and go into the machine learning.
In a world where billions of accounts are compromised, trust has never been more important. But how do you bring trust to the digital world? That's where NuDetect comes in. Trust is all about how well you know someone. Like Lisa. When Lisa goes to her coffee shop, her barista recognizes her familiar face, her name, her behavior, and has her usual order ready, a triple latte extra whip. If Lisa wears different clothes one day, her barista still trusts that Lisa is still Lisa, and she still gets the same great customer experience. NuDetect knows Lisa sort of like her barista does. It recognizes her patterns and builds a profile of Lisa that can't be imitated, even if her patterns change. Here's how. NuDetect uses 4 integrated layers to verify her identity profile. The first looks at Lisa's device, connection, and location. It knows that, even if the connection comes from Taiwan, it's actually Lisa using her usual iPhone 8, and not an imposter. The second layer looks at behavioral analytics. It knows that Lisa is a loyal Mac user, and always uses the latest version of Firefox. The third is passive biometrics. It knows hundreds of things, like how fast Lisa types, her typing cadence, and even the angle she holds her device. And the fourth layer is NuData's Trust Consortium. This brings together billions of anonymously stored data points across NuData's client base, and knows if Lisa is behaving like she normally does, or like a good user would. All of these layers are integrated, and know Lisa's profile with near 100% accuracy. You get the peace of mind that your business is protected from fraud. And best of all, Lisa enjoys the customer experience she deserves.
So now we're going to dive into layering threat intelligence so that way you can do model inference in real time and get results, scoring users and seeing, are they legitimate or not? So an intro to our architecture is essentially systems evolve. We all start at the monolith. We go through the microservice evolution, integrating containers and functions. We really look to leverage managed services, get rid of the undifferentiated heavy lifting, and dive in with lower operational overhead with a nice interface between systems. There's a key principle in here of creating a DevOps culture where teams own their stuff. If you made the model as a data scientist, you should get to own it end-to-end from inception through development to production.
What's interesting there, when I think about machine learning, I'm not necessarily going straight to DevOps. And obviously, I know what's coming down the slides, etc. But it's a very interesting concept that you're actually wrapping this in an ecosystem that you would traditionally sort of associate with traditional development, Java, etc. So it's a very interesting proposition that you're putting here. Should we?
So this is typically not something that people associate with machine learning. It's something that we all need to partner with different groups, as Werner said earlier. This is not just you have a security engineer specializing in this. This is the job of everyone. So when we think about the front end, we saw this briefly at the keynote where it slid across the screen faster than light. You can connect from your corporate data center, if you're still old school like that, or you can use your AWS account and connect to our edge, where we have Amazon CloudFront operating at the global level for customers everywhere. We have AWS Global Accelerator for those of you who want to whitelist particular IP addresses. And of course, we have AWS Private Link, enabling you to connect from your AWS account seamlessly into our environment. We can use elastic load balancing, application load balancing in particular, to segregate out different workloads onto different compute layers for our real-time scoring engine. That real-time scoring engine acts as a gateway to the machine learning experience into the microservice architecture, where we're able to have flexible compute with different entry points into the application and picking the right database for the right type of machine learning model. Typically, we'll pack up a model and run it within a compute layer and run multiple models within even the same system, with one operating as a challenger to the champion. From here, things jump into big data processing, where we're able to tunnel all those real-time events and start getting them prepped to do some model training. There's a question here around how much data do you need to do or need to collect in order to do big data learning? I think that big data is just a secret way of saying, I'm a data hoarder, please don't judge me. Every service generates data nowadays, whether it's telemetry data and metrics, system logs. But let's be real, more data equals more problems, especially when you consider GDPR, PSD2, all the different compliance and regulations coming out, and just taking an honest, good look at user privacy. Data-powered services are really wonderful, but we're in an increasingly untrusting world. Regulations have become extremely tough, and this is the space that NuData specializes in. So if we think of the evolution of big data and NuData, we've got a couple of slides here showing off the evolution. We started with the real-time system, just showering events into the back end, hitting a load balancer and having an EC2 instance upload them to an S3 bucket. Once that upload was complete, action number 2 there would be to send it into Elasticache, where it would be queued up for more work. Then an EC2 spot fleet could pull from that queue and batch process them, low cost, and shove them into Redshift or Cassandra. On the operational side, we were using CloudWatch combined with SNS and EC2 auto-scaling to control the size of the workload and to keep operators on their toes. When we think about the evolution here, you can only throw so much traffic through an ELB onto an EC2 instance before it starts to get cost prohibitive. We ended up adding our own queue system out in front using Elasticache instead, allowing us to aggregate the data more effectively before we pushed it into that workflow. We also swapped from Cassandra to Elasticsearch because we were growing as a company, and one database, we needed more options. It's interesting because this is where being an enterprise customer really is an advantage, being able to work with your SA and your account team and find out, hey, you're building this aggregation service. We're going to release a service in a while that is going to do this for you. This is what happened to us with Kinesis Firehose. Wonderful service. When they release that, the ultimate question raises its head. Do we need to be cloud agnostic, or do we want to be cloud native? Should we leverage this new technology to help us become more global scale, or do we need to be able to exist in a customer's data center? Ultimately, we did add Firehose. We added managed ES as well when that was released. And here is where our data workflow is currently trajecting towards, using Firehose as the front-end aggregator instead of all of these different processes. You'll notice that there's a lot fewer icons on this slide. That's from the simplification over time. That's the power of using those managed services to get rid of the undifferentiated heavy lifting and achieve better scale for yourself and for your customers.
What was the impact of that to your development teams? Because obviously, clearly, there's less that you're doing at this point in time. So what was the theme, as it were?
If you think of AWS costs, and I'm sure many of us here think of AWS costs when we're building a solution, this is like, hey, I'm running all these different things. Let's just turn them all off and watch our AWS cost bill plummet. It's a pretty good feeling when such a minor change has a huge impact like that. And when you focus on leveraging these building blocks, you unlock a lot of time for your own innovation, for focusing on what makes your business truly unique and truly powerful for the world at large. There are a couple understated benefits of the cloud that folks tend to gloss over, so I wanted to call them out. Minor changes in architecture can have large impacts. This is actually enshrined in the well-architected framework quite well. Everybody really talks about the security, elasticity, and paying for usage on the cloud. Very few people focused on the do not do undifferentiated heavy lifting. Focus instead on what makes your business truly unique and powerful. Because achieving innovation velocity, breaking into new markets, that requires focus and dedication. So we're all really here to talk about data ops, to really hear about how do you get that real-time model from just real-time scoring, everything else, from the big data hoarding, and actually repurpose that data to reinvest into your business. I'm going to start with some caveats. You're going to want to meet your new friend, CloudFormation, or any other component that you want, whether that's Terraform, the Cloud Development Kit. There are a lot of different alternatives out there. Honestly, it's a question of pick your poison. For us, we like CloudFormation because it integrates so well with Service Catalog, with the AWS Marketplace, and with AWS organizations. We focused earlier on DevOps. A lot of that is towards partnering with your fellow cohorts at the workplace. Taking DevOps, taking SysOps, security, whatever the specialized skill set is, and bringing them together, chatting, having that conversation, truly partnering with them and understanding their viewpoint and not viewing them as a firewall to throw your stuff over. I've been on both sides of that firewall. And the key principle here is if you build something, you should get to own it, whether that's a model or a piece of code. So if we think of a sample machine learning service that we recently built and tested out this workflow on, online application origination is a growing issue where people take your name, your social insurance number, your address, any piece of information they can get a hold of, and they use it to build a synthetic identity. This can then be used to create a credit card application, sign up for new services, do a lot of really terrifying stuff. And there was a question on our end about how do we defend against synthetic identities? And when we dived into the model development, we really had to focus on how do we increase our time to market, how do we engage with our customers, and really show them the value of what we do. As part of this journey, we managed to reduce model development time by 60%. And the more we practice it, the better we get. I'm pretty sure it's getting around like 70, 80%. from where we started. And we were able to use a variety of AWS services in the process, templating them with CloudFormation and using AWS Lambda and step functions to really bind together the ecosystem. So when you're thinking data science and you're thinking data science development, I find that there is a bit of a disconnect between network security and the data science engineer themselves. There is a portion of it which is actual true software development where you're working with Python or R or another language where you should be able to do that in Cloud9 or the IDE of your choice. Use code commit, GitHub, product of your choice. Integrate with CodePipeline or Jenkins. Do some build jobs, and ultimately push your software library into S3, where you're then able to use it for your actual data science development.
What was the decision here? Because obviously AWS Cloud is not, Cloud9 is not necessarily the first leaping pad for people to go to when it comes to IDEs. Jupyter notebooks, my apologies, would be an obvious choice. So what was the decision around that piece there?
So it depends on the type of development you're trying to do. And you can easily switch out Cloud9 for SageMaker notebooks, not an issue. You can also just use Visual Studio Code or any other IDE of your flavor or your choice. I kind of named my favorite one. Now, as you're going through this, though, what's important is the separation of duties. Being able to separate, this is me doing development of a Python library or R library or C or C# or whatever the case might be, and be able to focus on that and really have an honest-to-God conversation with your security team or anybody else floating around. And of course, there are some really cool tools that your data operations folks will have to be focused on, whether that's Service Catalog, AWS CloudFormation, AWS Config, CloudTrail, or CloudWatch. These are all great tools to provide visibility into the environment and control into the environment. From here, you're going to want to prepare a data set. And this is where the SageMaker notebooks become very critical. You're able to use SageMaker notebooks to work with Redshift Spectrum. Redshift can then pull the data from S3 and load it for you to work with, manipulate, and interact. If you're looking to distribute the workload, you can use user-defined functions written in Python that you've imported from that development workflow to change the data at scale, to manipulate it. From there, you have to be able to export the data for it to be pulled into the training workflow. And that's where we're, again, reusing S3. It's important to note that if you wanted to, you can take the real-time data from S3 and pipe it directly into a training workflow. Here, we notice that AWS Config and CloudTrail are prominently featured as a data ops tool. This is so that way you can track what's going on in the environment and understand what the configuration changes are, so that way you can feel confident and secure in your solution. From here, what most folks want to do, software developer, operator, or otherwise, is they want to be able to train a model. They want to get really into it. We leverage S3 and have events trigger. Basically, we upload the data set into S3. We have those events trigger AWS step functions, acting as the data orchestration layer. This is really important because we're able to use step functions to trigger different types of machine learning based off of an S3 path or any other type of arbitrary piece of information. AWS Lambda can then be used throughout the process to trigger different SageMaker workflows or to interact with other AWS services, whether that's DynamoDB or anything else you can imagine. You'll notice here that we really talk about CloudWatch and SNS. That's to monitor where you are in your model training process and alert based off of different metrics. If you want to go and host a model, you have a couple different options. You can host a model directly using SageMaker, having Lambda call out to the SageMaker endpoint, interacting with a service like DynamoDB. And you can use API Gateway to make it more friendly to developers or others that are consuming your service. You can add that authentication layer. You can add your subscription. You can integrate it with the AWS Marketplace. You also have options within SageMaker, such as weighted rollouts, A/B style. You have metrics to do champion versus challenger.
And so you've gone from end to end here. You've got a pipeline, so you've got the traditional CI pipeline, CD pipeline happening, all right? You mentioned earlier on that you had a number of efficiencies, and you're gaining efficiencies as time progresses. So is it just inherent in the fact that you've got this very tight iterative loop that's helping you in that respect, or are there other factors playing into this as well?
So there are definitely a lot of different factors. A lot of it is around the automation, about using CloudFormation to template out the environment, to really be able to move and pull in any service as they get released. Using Service Catalog, we're able to pull in those templates and make these types of workflows more accessible to every developer in the room. Whether that's somebody who just got hired that has an experiment they want to run, or that's somebody super senior and they're trying to tackle a challenge that's so complex I don't even understand what they're talking about anymore. That happens very commonly. An important thing to consider, though, and we go back to the layered feel of intelligence, model performance can vary depending on the complexity of that model. And of course, at NuData, we're all about real-time performance. So we aim to have the real-time scoring engine return our results in less than 300 milliseconds. Typically, that's running around 200, and of course, that puts a lot of pressure on model performance. In fact, typically, the most expensive a model can be is around 40 milliseconds, and that's in a most extreme case. Typically, we're trying to achieve between 1 and 10. That's a challenge, and that requires you to split up a model to get that type of layered feel. Earlier in the presentation, I mentioned splitting up and having the 4 different layers. Each of those layers is typically hundreds of different microservice calls, hundreds of different models. And the more that you practice this, the better you get. We might see a 20% reduction time on the remaining development time on every run-through. So if we're at 70 today and we do another run-through, maybe we get another 3%, maybe we get another 5%. It varies each time, but we tend to chip away at it. As we get better at it, we realize, hey, if we added this change to our step function workflow, we could do this other type of learning. Or SageMaker releases a new feature, and we're like, oh my gosh, gotta use that, gotta get a feel for it. Whether that's ground truth or SageMaker Neo, doesn't matter. So I have some sample code, of course, and it's on a PowerPoint slide, so don't judge me too much. I got it to look pretty good, I think, for the circumstances. It's really bad looking, I feel, on the slide, but the point is really simple. What if this is all it took for you to provide a product endpoint for a machine learning model?
Excellent. So once you've got this code, and you've got this entire pipeline, what are the next steps that you're looking at in terms of enhancing this whole flow for yourselves?
Making it more accessible and making it so that way any team within MasterCard, any team within NuData, any of our sister acquisitions, how can they really dive in? How can they get this to power every service that MasterCard and NuData build with artificial intelligence, with machine learning? How can we make this the new future? And in the code, you'll notice that it's quite simple. They get to specify the model endpoint, and then it can call out to SageMaker. It can pull in other microservices that we use to support our model development. And then it returns that data set back to the customer.
Excellent. No, I mean, so if you've got all this, so where are we going next with this in terms of where are you going next with this with AWS?
So our next steps, walking through and thinking about our direction, is evolution is key to long-term success. We need to be able to respond rapidly to new attacks because attackers aren't sleeping, right? They're constantly trying to innovate themselves, trying to get around whatever protective solution you use today. It's kind of like an arms race, like we're trying to win a war on fraud. And nothing is easy, and I'm sure we can all relate to that as we go about our day-to-day jobs.
So I'm going to kind of put myself on the spot here. What are the kind of things in ML you're looking for to really take you to that next level in that case?
Other than more design patterns about how we're implementing workflows and how we're doing dev, a better partnership between different job families and just the ecosystem at large. Having that honest conversation with our colleagues, with our cohorts, with everybody in the audience here. Having that discussion and keeping it going.
Excellent.
Now, if you're interested in NuData and NuDetect and our products, we're hiring. Apply. But you can also join the conversation, whether that's on Twitter or LinkedIn. We're really eager to hear from you, not necessarily to collect you as a customer, but to have an open conversation about machine learning on the cloud. And of course, if you're looking to reduce customer friction, we have a sales engineer on site, but you can also email us, take a peek at our demos. They're pretty cool. There are a lot of different types of fraud out there that you can interact with. And don't worry, the slides will be available after the presentation.
Excellent. Well, thank you very much indeed for that, Justin. It was really, really good. So I really appreciate you coming in. We have quite a bit of time left in the room.
Yes.
But we don't have microphones, so we can't do sort of a Q&A in a normal session. So what we'll do is we'll turn off our mics and we'll drop to the front. If you have any questions for Justin, please come on up and have a conversation. Thank you much indeed. Cheers.
And of course, if you like the session, please complete the session survey.
There's a good point there.
Otherwise, I probably won't be invited back. We kept it short so that way we can have some questions asked, so please make use of the time.